In this lecture, we will use the Gauss-Jordan method to solve the system of equations. The first equation is x minus 6y plus 4z equals 1. The second equation is 3x minus 5y plus 2z equals negative 1. Okay. You can see down here there are two equations and three variables. In this case, most likely is that they have infinitely many solutions. It's because the number of variables is greater than the number of equations. You will see why here. Now, let's take all the coefficients out and form an augmented matrix. Again, you know x, the coefficient of x is 1. It's not 0, okay? 0 times x, you get 0. So it has to be 1. 1 times x is 1. 1 times x is x. Now, so we have 1, negative 6, 4, 1. 1, negative 6, 4, 1. And 3, negative 5, 2, negative 1. 3, negative 5, 2, negative 1. Now, the Gauss-Jordan method is that row 1, column 1, this element needs to be 1. So we are done already. But we need the rest of the elements in column 1. This one needs to be 0. So each one multiplied by negative 3 on the first row and add to the second row, we will get new row, new second row. So 1 times negative 3 is negative 3, and negative 6 times negative 3 is positive 18, negative 3 times 4 is negative 12, and 1 times negative 3 is negative 3. And then you add to the second row, and you have you see the first row is not changed. 1, negative 6 for 1. The second one is going to be new. Okay, so it is negative 3, positive 3 cancel each other. Positive 18, negative 5 is positive 13. Negative 12, positive 2, we got is negative 10. And negative 3, negative 1 is negative 4. Add together. Now, Gauss-Jordan method also says that we need to make this one row 2, column 2. It was row 1, column 1. Now is the term for row 2, column 2 be 1 first. So then, in order to make this one be 1, we divide this number by itself. Then we can easily get 1. Okay? So row 2 divided by 13 everywhere, and then we get new row 2. So this one, new matrix, might be easy. 1, negative 6 for 1 is not changed, so we keep it. And then the new second row is 0. You know, you may say, why not here? But again, 0 divided by 13 is 0. No, alright. So 13 divided by 13 is 1. And negative 10 divided by 13 is negative 10 13th. And negative 4 divided by 13 is negative 4 13th. Now, we made this one, row 1, column 1. Row 2, column 2 is 1 already. Now we need to make the rest of the elements in column 2 be 0. So this is the only one. And then we know if this row, this element, this row, multiplied by 6, positive 6, and add to row 1, then this guy, negative 6, this element is going to be 0. So what we do is row 2 multiplied by 6 and add onto row 1, we got a new row 1. Okay, so what do we get? Yeah, and then we have 1 times 6 is 6, add on to that we have a 0. Okay, again you may do is here is 0 times 6, you add on that, 0 times 6 is 0, you add to that, you then have 1 still. Now here is the thing, 4 you have a minus 10 over 13 times 6. 10 times 6 is 60, then over 13. The second one is 1 plus negative 4 times 6, so you have negative 24, and here is 13. Okay. The second row we didn't do anything. 0, 1, negative 10 over 13, negative 4 over 13, we keep it. Okay. The thing is that we need to add those fractional numbers. You see those two we need to calculate. Okay. Now, here I add a little bit more details. You know, integer subtract a fraction is what? Is 13 over 13 times 4. 13 over 13 is 1. 1 times 4 is still 4. So here I do 13 is because down denominators needs to be 13. Okay. So, what do we get? Here is the calculator. Like 13 times 4, 13 times 4, and then minus 60. Minus, I should do is minus 60. So it's actually negative 8. So numerator is negative 8. So this is how I put right here. Okay. Numerator is negative 8. Downstairs is still 13. Similarly, 1 is 13 over 13. Okay. And then 13 minus 24 is negative 11. And here denominator we keep it 13. Alright. Now the second row we just keep it. We didn't do anything. So 0, 1, negative 10 over 13, negative 4 over 13. Up to this far, you know, remember this is augmented matrix. Always remember the last column is actually the constants. Okay, and then here is the constants. Up to this far, you have 1, 0, 0, 1. Then you can see down here, you may write it back. The system will be like this. 1, 0, 1, 0, that's x, y. And then minus 8 over 13, z, equals negative 11 over 13. Now, the second one is 0 times x plus 1 times y minus 10 over 13 z equals negative 4 over 13. Okay. Now, you know, up to here we need to get this one to the right hand side. And so is the one right here. It needs to go to the right. Here is negative 8 over 13z, so you plus 8 over 13z on both sides. Okay, then you can cancel it. If you cancel that, then the left-hand side is, you see 0 times y is 0. So you have only 1 times x, which is x, And the right hand side is negative 11 over 13 plus 8 over 13z. Okay, and then the second one is similar. It's 0 times x, you get 0, and 1 times y, you have a y, equals, those two are cancelled. Okay, you see down here, if we do that, both sides plus 10 over 13z, this is 13, okay, 13z, negative 10 over 13z, if we plus 10 over 13z, 10 over 13z, then what do we get? We then get those two cancelled. Alright, so that will be negative 4 over 13 plus 10 over 13z. Okay, so x then equals this one, the sum of two quantities, and then y equals negative 4 over 13 plus 10 over 13z. Okay, so this is actually the final solution. Why we say that this is actually the infinitely many? Because for each z, you have a different y, x and y. If a z is 1, you can find a number, and then you have an x value. Z is 1, you can have a y value. If z can choose 2, you can have another new value for x, another new value for y. Z can be 3, can be 4, 5. You all get all different x, y's. So that's why we say in this case is infinitely many solution. And some book say that z is a free variable. Some book didn't mention that. Okay. All right. Please review this lecture. I'll see you next time.